Hello guys, I am Bhumi. Welcome back to my channel. So in this section we are going to talk about that by observing any quadratic equation or its graph with its equation, how can you find the focus and the equation for its directress? Is that right? So how can you do so? For that, what you need to firstly understand the basics. As you know that this is our parabola. Every quadratic graph and its equation have only one focus, because what you know about focus is that it's a point and there is a fixed line from where the distance is always equal, that this distance is equal to this distance, right? And when you draw this, like this distance will be then equal to this distance, and all the lines that are coming from this parabola will be perpendicular to this directress. Is that right? These all lines are perpendicular. Okay, now what you need to know is that you will think that it's like this, which is our perpendicular, right? Perpendicular to this. And when you draw a hypotenuse, or you can say that it's a perpendicular and it's a hypotenuse, then you know that a perpendicular is always smaller than hypotenuse, right? So how can you say that this hypotenuse is equal to this perpendicular? So for that you need to know that this perpendicular, and when you draw the perpendicular of this, these two perpendicular are not equal. What I mean to say is that this perpendicular is somewhat larger than this perpendicular. That is why, because if this perpendicular will be smaller than the hypotenuse we will obtain by this perpendicular, and this base will be larger, that means this the hypotenuse will be larger than this perpendicular. That states that the perpendicular you obtain by this triangle, this perpendicular must be this perpendicular. Let's say that this perpendicular number 1 and this perpendicular number 2, right? So in this, by observing this, you can say that the perpendicular number 2 is larger than that of perpendicular number 1. Why? Again I am telling you, because this perpendicular have its hypotenuse. This hypotenuse can be this, can be this, can be this, can be this, always, but that hypotenuse must always be larger than this perpendicular. Is that right? And if you observe this, then you know that this distance is equal to this distance, right? That means this is our hypotenuse of any right angle triangle, so the perpendicular you obtain must be smaller. That means this distance, this perpendicular number 2 is not equal to this perpendicular number 1. So this perpendicular number 1 is smaller than this perpendicular number 2. Okay, now you know that let's say that this equation is equal to y square equals to 4ax. Again, this a is the focus. Is that right? This a is the focus, this length. Okay, now what I need to tell you is that the distance between these 2 points are equal, and the distance between these 2 points are also equal. Is that right? Similarly, what you can do is that you need to just draw a perpendicular here. The perpendicular on this point, which is this line. Okay, this line, when you draw again the perpendicular from here to this point, from this point you need to draw a perpendicular on this line. Is that okay? Now what you know that this distance must be equal to this distance. Is it right? This distance must be equal to this distance. Now you know that if this distance is equal to this distance, and you know that this distance will of course equal to this and this, that means the shape you obtain by this is square. Is that right? Again, you know that as you have drawn a perpendicular from here, then from here, let's exceed this graph, then from here you need to draw perpendicular like this. You know that this line, this distance is equal to this distance, right? This distance is equal to this distance, right? Now you know one thing more, that this distance, the distance from this origin to this point, this focus, is equal to the distance from this O to this M, right? Why? Because I have told you that the distance from this point to this line are equal, that the distance from this is equal to this, and this from this to this. Is that right? Now as you know that this distance is equal to this distance, that means if you need to find this distance, then this distance will equal to half of this whole. That means if I need to find this distance, this will be half of this whole distance, or you can say that this distance will be half of this whole distance. Why? Because this line is equal to this line. Is that clear? As these two lines, this line is equal to this line, so let's make this intersection point as P, which is x, y. Why I have put in here xy? Because I know that all the points lying on this quadratic equation is satisfied with that. Means if I put some value, let's say the x equals to some value that -2, it will be not here -2, the x is equal to 2, means this a is equal to 2, then what I can say that this point, and then by putting this 2 in the quadratic equation, I will get this y, and this y will be this y will be this distance, right? I have put in this 2 as this, right? And this y, when I get by putting in the quadratic equation, I will get this distance. So what I need to tell you is that I am considering this point as xy. Okay, now what I am doing is that I know that the distance from here to here is x. That's why I have put in here xy. So the distance from here to here will be, as this is lying on the x-axis, so the y will equal to 0 and the x will equal to x. Why I have said that this point will be x0? Because I know that this line is parallel to this line, and the shape you are obtaining from here is rectangle, and the rectangle has opposite sides as equal. Okay, so this point you obtain is x0. Now this point, what this point will be, here the point you obtain from this is equal to minus x0. Why minus x0? Because you know that if this is x, then it will be the negative magnitude of this. That means this will be minus x, and you, as you are obtaining this point on the x-axis, that means y will equal to 0. Now when you exceed this line, the point of intersection on this directrix, we will say this point, you know that this is parallel to this, and the shape you are obtaining from here is a square. Why square? Because I know that this side is equal to this side, right? And this side is equal to this side, so all sides are equal. As all sides are equal, so the figure you obtain is a square. That means the distance from here to here is, you know, that is y. That means the distance from here to here will also y. So what will be this point? Will this point will be as you know that this is minus x, so when you exceed this line it will be again minus x. Okay, have you understand why I have here taken the minus x? Because we know that this equation is what? Here the x is equal to minus a. That minus a is a simply x, right? Is that right? That minus a is simply x, because I have said that this is a0 and this a0 is equal to x0. That means this a is equal to this x. Okay, now as this is a minus xy and this is xy, you know that I have told you that this distance, the distance between this point and this point is equal to the double of the distance between this point and this point. So let's suppose you have an equation y squared equals to 12x. Is that right? So here what you can observe is that this y is equal to twice of x, right? Why I have said that this y is equal to twice of x. Only when this will be equal? Only when this point will be on focus, or you can say that only when this point will be on at that distance where this distance is equal to half of this distance is equal to double of this distance, right? So when you put this y equals to 2x here, then you will observe that this will be 2x square equals to 12x, right? This will be 4x square equals to 12x. This x will be cutted out. You can simply say that this x is cutted out and this will be cutted out as 3. So here you get the x equals to 3. What does this mean? This states that your value of x is equal to 3. What does this mean? This means the point the point from where the distance of this line is the distance of this line is something y, you can say, and the distance of this line is 3. That point, the point where this distance is half of this distance, right, that point will have x equals to 3. So how can you obtain the value of y now? How can you get the value of y now? You know that the y is equal to 12 into x, right? You know that this y square is equal to 12x. When you put this value of you know that the point when the x is equal to 3 and the point lies on this line, this quadratic line, this quadratic graph, then the value of y you obtain, the point there, the value of y you obtain is under root 12 into 3. What is that? Under root 36, which is equal to 6. That means the point, this point, that the point on quadratic graph will be x equals to 3 and y equals to 6. You will observe that this satisfies that y is equal to 2 into x, as we have proved before. This y equals to, here this 6 will equal to 3 into 2, which satisfy the equation that we have formed, right? So here the conclusion that comes out is that you can all the time, by observing the equation, whatever the equation is, you can just see that what the distance, you can simply say that first of all you need to find the equation, right? As I have find here that y equals to 2 into x. Similarly, the equation can be x equal to 2y. These two equations are not equal, but this equation can be true when, like I am drawing a graph, that when this when you have this like graph, here you can see that the x square is equal to 4ax, right? So how can you find the relation that in the before graph I have find the relation that y is equal to 2 into x. Now how can you see how can you find the equation here is that you know that you need to find like this is our directress. Okay, we can't draw the directress directly, but I am now only supposing. So you know that the distance from here to here, now the distance we need to first of all draw the perpendicular, right? And then we know that the distance you are drawing from here must be double to that of distance you are drawing here. That means let's suppose this distance here is fm and the distance from here to here is p. That means the fm must be equal to double of pm, right? Why? Because you know that you want to obtain a square. Okay, you know that you want to obtain a square, and in that square you know that this side is equal to this side, and you also know that if you want to find this and this, let's draw it fairly, that this distance from here to here, let's suppose this distance as this is f, this is m, and from here to here this distance must be half of sorry, the distance from, you know that you need to obtain a square, right? Like I am first of all, you know that the distance from here to the directress, like this is our directress, the distance from here to here must be equal, right? So you know that you need to draw a line that this distance, the distance from here to here, must be half to this distance. Is it right? The distance from here to here must be half to this distance. So you can say the distance from here to here is what? Y, because this is our y axis, and the distance from here to here is what? X. So you can say that this y must be half of x, right? So what you obtain from here is that when this 2 will go there, you will obtain that this x will equal to 2y. What does this mean? This means that when you were whatever your equation is, let's say that this equation is x square is equal to 12y. So you have proved that this x must be equal to twice of y. Here let's make it clear. That the distance from here to here must be double of that. That means this x must be double of this y. And so when you put, you know that this point will be x, y. Why? Because you know that this distance is x, right? And this distance is y. You know that this you can say from here, because this will be minus x, simply you can take this side. You can say here that this point, the point you are obtaining from here, just highlight it with another color. This point is x, y. Is it clear? This point is x, y, and this x that will be equal to twice of y. Means the distance from here to here is y, and the distance from here to here, the distance from here to here is x, and from here to here is y. So when you put this is our point x, y, which satisfy to the equation of our quadratic graph. Is that right? This x is equal to 2y. That means when you put this as 2y square is equal to 12y, you will obtain as a 4y square equals to 12y. This gets out with this and this will with this. Then it says that y must be equal to 3, right? That means this equation have any point where the y is equal to 3. That means at that point the y is equal to 3, and obviously this is the double. That means this distance will be 6. Okay, this you can prove this by putting here also like a 12 into 3, and its root will be our x. That root can be positive and negative. That means the x value is equal to positive 6 or negative 6, right? That means that point can be this point, just highlighted with another color, that the point can be this point where the x is minus x and y, and can be this point where the point x is x and y, right? That means this distance, that this coordinate which was somewhere here, this coordinate is the distance from here to here is what, minus 6, and from here to here is what, 3. That means this can be minus 6 and 3, and the point that was somewhere here, the distance from here to here is 6, positive 6, and from here to here is a positive 3. That means the point which was on this quadratic graph, this point can be 6 and 3, and can be minus 6 and 3. What you obtain from here, first of all clear this. Here the point is this distance is 3, and this distance is minus 6. This distance is minus 6, and this is 3, and again this is 6, and this is 3. Now what you think, what you will observe, as you know that this distance will also 3, you need to draw a same distance from here, because you know that if you are drawing a directress, then the directress will be at the same distance. From the distance from here to here, the focus will be equal to that of directress. That means your directress will be somewhere here, right? That you will came to know that this distance is now minus 3. As you know that this is our x-axis and this is our y-axis. That means the point here will be the 0 and minus 3, right? And the equation you obtain is that the directress, let's suppose that directress is you know that say it as y, right? That y is equal to minus 3. Simply you can say that y plus 3 is equal to 0. Is that right? This line has the point here as the minus 3. That means this 3 is, this 3 is the, this 3 is a not our focus but the value of a. Okay, you can simply say from here that you know that x square is equal to 4ax. You can say that whatever our x is 6. That means that it is 36 equals to 4 into a. What again, this is y, right? This is y. Whatever y is into 3, that means 36 into 4 into 3 is what, 36 equals to 12 into 8. This will cut out at 3. That means a will be taken out as 3. That means this distance is 3. Okay, Simply you have got your equation for your directrix, that is y plus 3 equals to 0. Okay, graph equation is y is equal to x square plus 2x plus 1. So you know that when you put here 0 you get y equals to, when you are putting here 0 you will get y is equal to 1. When you put it as minus 1, then what you will get is minus 1 square, that is 1, and minus 1, that is minus 2, minus 2 and plus 1, which will be minus 1, and this plus 1, which will give you 0. That means when you put to x equals to minus 1 you get y equals to 0. That's the same point here, which will be said to be as minus 1 and 0. Is it clear? Now simply we will again form an our relation between x and y. Okay, let's say that when you are drawing a perpendicular from here, that means when you are drawing its axis, what axis is? Axis is a line. Simply axis is a line which divides this quadratic graph into two halves. Is that right? That two halves are equal. That means the perimeter of this line and the perimeter of this line will be taken out as equal, and all the points that are here will be the same point represented here. That means the distance from this axis to this point is equal to the distance from the axis from this point. Is it right? Now when we draw here a axis that passes from the point that is minus 1 and 0, the point is here minus 1 and 0. Is that right? Now okay, this is our axis and this is our coordinate of this point. Now would you know that you need a point on this quadratic line, from where from the axis which has the distance, which distance is double, right? Which distance is double from this point which is here to this point. Okay, you know that that point will lie on this line, right? That point will lie on this line, and all the points that are on this line have the abscissa, have that abscissa as minus 1, because all the point will have the same abscissa, right? And will have the different value for y. Okay, let's say that point lies somewhere here. Okay, I'm just highlighting that by another pen color. That point is somewhere here. Okay, now you know that from this point the whatever our y is, let's say that y is written here as y, and this is our ordinate. The ordinate is our variable, and the abscissa is our constant, because we know that all the point will be lie on this line only, and all the abscissa here will be minus 1. Now what I need to tell you is that again this distance from here, that this what the distance is, you can obtain that this is our minus 1 y, and this point has minus 1 and 0. So the distance between this and this will be given by y2 minus y1 all the square plus x2 minus x1 whole square equals to what? This distance from this point to this point. Is that right? Now what I need to tell you is that what our y square, let's suppose this is our y square, so let's suppose this is our this y which is written here is our y square. So y subtracted by 0 is you know that that will give you us y. This is our square minus x2. What our x2 is, let's as you know that you have taken this as a y2, so this will our x2. Okay, then this will be minus 1 minus minus 1 square. This minus will be then plus, and minus 1 plus 1 will give you 0, and it will be simply as y square under root, which will give you as y only. Okay, up to here there is no problem, right? Now you came to know that the distance from this minus 1 comma y to this minus 1 comma 0 is y, right? The distance from here to here is y. Okay, so now what I need to do is that I know that the distance from here, from this point, let's suppose this point here, which is from this point to this point, right? Let's suppose taking here this point as P, this point as M, and this point as N, right? Now I am saying that this PM, you know that you want that the figure you obtain by must be a, this figure must be a square, is that right? As you know that this will be square, that means this Pn must be equal to twice of Pm. Simply you can say that this Pm must be equal to half of this Pn, right? That means, as you know that this Pm is what, you know that this Pm is our y, and what this Pn is, you need to find that Pn. Let's suppose that this point, what was this point? This point was minus 1 comma y. What this point will be, we don't know our x coordinate here. We know that the point which will lie on this the point which lies on this quadratic equation will of coursely satisfy the line, right? That means the distance from here to here, as this distance from this Pn is y, and this line is perpendicular to it, right? You know that I am drawing the perpendicular from this point P. So as you know that this distance, the Pn is perpendicular to this x-axis, that means this line will be perpendicular, this Pm will be perpendicular to this line. So you know, as this figure you obtain is a rectangle, that simply means that the distance from the this x-axis to this n will be y, right? This y will be same as this y you are getting on this point of the quadratic equation. So it will simply xy, right? This xy. Okay, you know that the distance, first of all you need to calculate this Pn. What this Pn will be, this Pn square, you can say that just drawing here, this Pn square will be equal to my x minus 1 square plus just writing in a straightforward line, that x minus 1 square plus x minus 1 square plus y minus square, right? This will be just cancel out, because y minus y, as we know, that will be 0, and 0 square is also 0. That means the answer you get by Pn square is x plus 1 square. This when this square will come here and become as under root, this will then cancel out. That means this Pn is equal to x plus 1. Is it right? Now what you need to know is that, as you know that the distance, this Pn, as you know that this Pn is double of Pm, right? What this Pn is, you have taken that Pn, you have find it out. what this Pn is. This Pn is x plus 1 and this Pm is y. Okay, so what are the thing you get is x plus 1 equals to 2y, right? Why? Because this is our Pm, this x plus 1 is our, is it Pn or Pm? It is Pm, right? That this x plus 1 is our Pn and Pn is equal to twice of Pm and this Pm is y, so you have just put it 2 here, right? Is it clear up to this? Now what you know is that this x plus 1 equals to 2y. You know that this y will lie on the quadratic equation, right? What this quadratic equation is? This quadratic equation is y square equals to, sorry, not y square, it's y only, that y is equal to x square plus 2x plus 1. That means you can put this value of y. Why I am taking this value of y here? Because I know that this point will be lie on here and this point has the value as y, and this y is taken out by this equation, right? And this x and this y both will satisfy. When you put the value, whatever your value of y is, when you put that value here, you will get the value of x. This x will be the same as x you are obtaining here, right? That means the x plus 1 equals to 2y. Here you can put the value of y, which is nothing but x plus 1 equals to twice of what the equation is, x square plus 2x plus 1, right? That means x plus 1 equals to twice of x square plus 4x plus 2. That means this one, this 2 came here, you can simply say that when this go there, and when this 4x came here, it will be minus 3x. This when this 2 came here, it will be minus 1, and when this came here, it will be somewhat 2x square, right? That means minus 2x square. This is equal to 0. You can take out the minus as a common, right? That means you take this minus here, you need to just put here minus, put here minus. This will be positive and minus 0 is nothing but this will be just cancel out. That means this 2x plus not 3x, this 2x square plus 3x plus. So here you need to just apply the quadratic equation formula for finding the roots, that is minus b plus minus under root b square minus 4ac divided by 2a, right? When you apply this, you will find that minus 3, first of all I am plussing, okay, minus 3 plus under root 3 square, that is 9, minus 4 into ac, that is 8, right? Divided by 2 into 2, that is 4. You will get that minus 2 divided by 4, that is equal to minus 1 by 2. Is that right? Now what the other value of x you can, the value of x you get minus 1 by 2, right? What the other value can be? Minus, that was minus that was a positive 1, right? And divided by 4, that is minus 4 divided by 4, which is minus 1, which was the initial value. Say here this was the value as minus 1 0. This is the x value, right? Which is in the second time we get that the x is equal to minus 1 and the x is equal to minus 1 by 2. What does that mean? This means that the value here located, I am just highlighting it with the other color, that is here, the value of x you are obtaining is minus 1 by 2. So the question arises that what will be the value of y? So you can get the value of y by putting the value of x in this equation, because this equation y is equal to x square plus 2x plus 1 satisfy this whole quadratic graph. That means if x is located somewhere on this graph, that means you can find the value of y also. So how can you find this? This can be minus 1 by 2 square plus 2 into minus 1 by 2 plus 1. This will be cancelled out and this will be positive, because a negative into negative will give you positive. That means 1 by 4 plus this will be negative and this will be positive. That means the value of y you get is 1 by 4. Is that right? That means, that simply means that, so here this we get that the value of x is minus 1 by 2 and the value of y is 1 by 4. That means we know that this whole is our 1, right? This whole is our 1. As this whole is our 1, that means this will be our half and the value of y will locate it somewhere here. This whole 1, this distance is half and this will be 1/4, right? So let's draw it with another color. This distance will be equal to y, okay? And the distance, and this distance, which is the value of x, will be what? We know that this whole is 1, that means this will be 1 by 2, and it, as it is in this direction, that means as it is in the x dash axis, that means this will be negative, okay? So as this distance is 1 by 4, that means the directress will be located at the same distance from this line. The distance is 1 by 4. That means from this line the same distance will be downward direction also. That means the directress will be located here. Is it clear? This point is minus 1 by 4. What does that mean? This means that let's suppose our directress is y. This y will equal to minus 1 by 4. That means y plus 1 by 4 will equal to 0. This will be our equation for directress, okay? Is it clear? Now the coordinate for focus will be what? As we know that this point was a minus 1 and this distance is 1 by 4, that means the coordinate will be minus 1 by 4. Is that clear? Thank you.